Welcome to this video on Dalton's model of the atom. This lesson is the first lesson in the Atomic Structure and Periodic Table chapter of the Key Stage 3 curriculum. And it's a really interesting one, and I remember when I was planning this lesson, I had to do quite a bit of reading myself, because it really forces us to go back and unpick some things which to science teachers and indeed to many students just seem really commonplace. Because to really get inside Dalton's model, we have to try and understand the time in chemistry before we thought in terms of particles. And any year 7 student, in fact, this goes back into the primary curriculum, into kind of year 4 and 5, they'll be familiar with thinking about solids, liquids and gases in terms of particles, or really in terms of Dalton atoms. But what I think is helpful for students is to show that this isn't just a fact that's really obvious, that we're just telling them. People had to put forward this idea, and there's good reasons for believing it to be true. So really the question I would start with students is, what is a gas? And again, students from year 7, they'll have this knowledge, oh well, a gas, particles far apart. But if you probe and really get them thinking, you might pick out some interesting misconceptions. And what we're going to do is try and address those by thinking about what people thought about gases before Dalton. So I'm going to write before Dalton here. And I'm going to write what the guess was. Now, again, this is one thing that I had to read up on, but before Dalton, gases, they were seen as these kind of fluids. And effectively by fluid, I mean a continuous kind of material. So what you might do is show something in here. And the point that you want to emphasize to students is, if we imagine this down at kind of a very micro scale, before Dalton, scientists didn't think of that in terms of particles. They thought of it as this almost like a fabric or something, this continuous stuff that kind of swirled around like that. But what was interesting was the way Dalton came to his conclusion that this guess could not be correct. So this is the second stage of our model for how scientific knowledge is generated. And what Dalton, and in the slides there's excerpts from his paper which describe this. But what he said was, well look, hang on. If this is the Earth here, so I'm going to write E for Earth in here. Well, we know by this point, since the time of Torricelli and all that stuff, the barometer and etc. We know that there's this kind of sea of air, that atmosphere, sitting all the way around the Earth. And what Dalton said was, well, hang on. We know that sea of air has various gases in it. So if we take a cross section here, like this, well, let's zoom in on that part there of the atmosphere. And his point was, well, if this guess is true, that I might label this that gases are fluids, these continuous fluids. If that guess is true, well, just like oil and water, when you pour them into a beaker, and this might be something you want to demo to students, they separate out, and the more dense fluid, which in that case would be water, goes down to the bottom, the less dense fluid goes to the top. Well, he said that's what you'd expect to happen in the atmosphere if this fluid guess was true. So what you'd have down here is the densest fluid, or the densest gas, which might be carbon dioxide. Then you're going to have your oxygen. So I'll put this I'll do something like that, show that it's a different layer. So then you've got your oxygen like this. By this point, early 1800s, Priestley and Lavoisier and others, they know all about oxygen and nitrogen and so on. Although, yeah, I'm doing CO2 and O2. Obviously, Dalton didn't think about it in that way at this point. That came with Avogadro later. But anyway, then you've got your nitrogen up at the top, and so on and so forth. Essentially, what Dalton realised is, if gases were a fluid, then the gases in the atmosphere would be stratified. They'd be in layers like that. But at that time, scientists already knew that just wasn't the case, that all of the gases were kind of present in all parts of the atmosphere, just in varying proportions. So the final stage is to do a check and say, well, hang on, do the deductions from our guess agree with reality? And in this case, they didn't. So Dalton needed to come up with a new guess. And as I'm sure everyone watching this video is aware already, the guess he came up with was to say, well, hang on, maybe all matter, including gases and other things as well, instead of being thought of as these continuous fluids, maybe we can consider it as being made up of these very, very tiny particles, zipping around all over the place. So now we're showing students what we talked about in year 7, which is that if you've got a pure substance, what that's made up of is identical little particles, and really they should all have been the same size. And if you want, you can add the arrows and stuff. That's more of a physics thing really, but you can add the arrows in random directions to show that motion, and you can revisit some of the particle model stuff that they did earlier on at school, and so on. Now, Dalton didn't just stop there. He didn't just say, maybe it's made up of particles, and that's it. He said, well, okay, let's go back to our picture of the Earth. Here's the Earth again. I'm going to draw an E for Earth to show that. Here's our sea of air, what we call the atmosphere, like this, going all the way around it. And he said, well, if matter was made up of tiny particles, what you'd expect to happen is there'd be kind of an even distribution of these particles all the way throughout the atmosphere. So let's do our our CO2 ones, dark ones like that. You'd have some of those all over the place. Because there's more oxygen than there is CO2, you'd expect to have a lot more oxygens. Maybe I've done too many CO2, too many CO2s, but anyway, hopefully you get the idea. And then you'd have lots of nitrogens like this. The point being, understanding gases in terms of particles gives you a much better description of what the Earth's atmosphere is actually like, i.e. all the way through you've got a mix of these oxygen particles, these carbon dioxide particles, and these nitrogen particles. You've got this kind of this mix all the way up through the atmosphere, not these layers that would have been predicted if gases were this continuous fluid. So this was Dalton's guess. This is what he deduced from it. Is this what we expect to happen? Is this what happens? Well, yes, this is pretty much like it really is. So that's why people thought actually Dalton's guess gives us, this is a step forward in science. Now the last point to say is we so far in our science lessons have just called them particles, and typically, I mean, I teach this lesson to year 9. Typically when I do chemistry in year 8, I don't bother talking too much about atoms even then. I'm more than happy to just draw the particle pictures, kind of the hard spheres, and just leave it as particles. But we can really officially introduce this word atom here, let's say, even though they've almost certainly come across it before. So we can label this as atoms. And you might just want to give them an idea of where that word comes from. It comes from the Greek word atomos. And if you want, you can go back to Democritus, this philosopher. He wasn't a scientist. He didn't think about kind of making models, deducing testable hypotheses from them, and then doing experiments like modern scientists do. He was a philosopher. He thought logically. But he said, well, hang on. If you take a piece of paper and you cut it in half, well, then you've got a smaller piece of paper. Probably not paper, whatever material it might be. But if you then cut it again, you've got a smaller piece. If you cut it again, you've got a smaller piece. So on and so forth. But he thought, well, there must be a point at which you just couldn't cut down that material, let's say paper, anymore. So there must be a point at which it becomes uncuttable. And that word atomos means uncuttable. He just thought logically there must be some point at which you can't break this down any further. And that's worth stressing about Dalton's atoms. So Dalton thought gases were made of these atoms. And the main point about these atoms, they're these hard spheres, and we can tell students these are hard spheres. But the really important point, and we're going to come back to this again and again in the next few lessons, as I'm sure you know, is that these atoms are indivisible. You can't break them down any further. So that was Dalton's guess. We're going to find out how Thomson disproved that guess in the next video.